Hi everyone. So thank you so much for joining me. I'm Sam, the founder of the Arweave protocol, and today I'd like to tell you a little bit about it. So put simply, Arweave is a blockchain re-engineered to store excessively large amounts of data inside the chain itself. It is on-chain storage that scales. Well, why would you want to do that? The human collective, I guess, has had this strange desire to store all of its data or all of its ideas across time, essentially since the beginning of recorded history. This is what we know about the world. It comes as a result of this record that we've built together. We see with Arweave that there is an opportunity to revolutionize that concept of storing information for large amounts of time. The problem with the existing systems that haven't really been updated for literally thousands of years at this point, archives, libraries, galleries, is that they all have single centralized points of failure. Well, that doesn't have to be the case anymore with blockchains. You can build a system that replicates data in many places around the world, such that it can withstand, fire, flood, government damage, whatever it happens to be. And that's essentially what we set out to build: the collective knowledge store for humanity that stores our history and all of the things that we think are important to remember tomorrow, in a way that we can verify that they haven't changed over time, and that we can verify that they won't be lost using incentives. So how do you actually do that? Well, or rather, why first would you want to do this? There's a nice sort of quote that is attributed to Winston Churchill, although we're not quite sure that it comes from Winston Churchill because we've lost those records, that says that history is written by the victors. This is a really important sort of problem to solve. We see that the records of history that we have from the prior world are created by the people basically that have control in the present time, or as George Orwell put it, the person that controls the past controls the future, and the person that controls the present controls the past. So the person that controls the power in the present day gets to control what information about the past is preserved, and by controlling the information that is preserved about the past, you can change the way that people act in the future. It's a little bit strange a concept, but it's actually quite fundamental. And what we want to create is a knowledge storage system, or a history storage system, that replicates information in a neutral manner, and anyone can contribute information to. So history isn't just written by the victors. History is a neutrally recorded fact. That's the point of the Arweave project. So how do we actually achieve this? Well, we have to solve two problems. First, we have to solve the problem of permanent storage sustainability. How do you make it so that you can actually pay to store data forever? Sounds impossible, right? And the second thing is technical scalability. So how do we make it so that a blockchain can actually fit large amounts of data inside? We have a hard enough time processing more than 13 transactions per second, even on Ethereum in 2022. So how do we make it so you can fit arbitrary amounts of data inside? Well, let's start with that problem first. The answer to this, it turns out, is a system that we call succinct proofs of random access. Basically what we say is, okay, we change the mining process so that instead of just looking for who can burn the most energy to generate the most coins, instead we say, okay, you generate a random challenge every time you do a guess in the proof of work game. And that challenge is a byte in the network. And then we organize these systems of succinct proofs using Merkle trees so that you can go from that individual byte to a small chunk of data, and then create a proof that that data is in the right place in the network. And so we say, okay, the person guesses something and they get a random offset in the data set, and then they recall that data, and then they hash it again, and then we see if that satisfies the sort of traditional proof of work difficulty game. And what this means is when you're a user, you can now upload this Merkle tree of the data that you want to include, and so you don't have to upload all of the data to the chain itself, yet you still get the properties of on-chain storage. So now that scales arbitrarily wide, and you can use this thing we call bundling to put multiple data sort of entries into the same base layer transaction, so that makes it arbitrarily scalable horizontally and vertically. And then as a miner, to be rewarded, you have to prove that you have access to as much of this data as possible. And there are a few other mechanics to it, but this is the broad principle. Okay, great. So now you can fit arbitrary amounts of data inside a blockchain, but How do you make it so that that's actually sustainable? Well, you create a decentralized endowment. Endowments in the normal traditional finance world are used by things like universities, so that they put aside a fixed amount of capital, they generate yield on the capital, and they use the capital to pay for tuition fees for students to come through the university, that kind of thing. But in our system, we do it slightly differently. So we say, okay, when you put data into the Arweave network, you pay for the storage of that piece of data for 200 years. That sounds expensive, but actually storage is relatively cheap. So that's half a cent per megabyte, which is, for things like NFTs and this type of thing, it's a fraction of what you would spend on the ETH or Solana even, or Near or whatever it is, gas fees. Okay, so you pay for the storage of data for 200 years. Then as the cost of data storage declines over time, that 200 years extends out. And as long as that cost of storage declines at a rate higher than 0.5% in a year, you actually end up with more storage purchasing power at the end of that year than you had at the start. And in this way, you can essentially make a storage system that is sustainable over thousands of years, as long as that property of storage cost declines staying above 0.5% continues to be true. At the moment, that storage cost decline rate is about 10 to 30%, depending on the year. So that's a very, very wide margin of error. And that doesn't seem to be slowing down anytime soon. And then even if it does, even if it stops completely, then you have hundreds of years worth of cost to pay for the storage in the system already. So it's extremely long-term storage, like into the thousands of years in an economically sustainable way. Okay, so we built this system and launched it in 2018, and it's been growing at a sort of exponential rate ever since, which is fantastic. We see that now there's a sort of another layer developing on top of this base, which we call the permaweb, which is all of the information stored inside this system made available in people's web browsers. It's essentially a global permanent web. The web was like this idea that we could build what they called at the time a distributed knowledge graph. So I could have a website over here that describes some knowledge, and it could link to a piece of knowledge that's stored on your website over there. Well, what we've done with the permaweb is we've said, okay, well, what about if we can do that, but also over time? And we can make sure that it's not just that your data is stored on that server over there, it's actually stored in a way where it's replicated all across the world in a sustainable fashion, so it's not going to disappear. It's like the nth degree of where the web was trying to go. It's the neutral knowledge storage layer. And at the same time, you can actually see when pieces of information were added to this permanent web. So you can look at the transaction ID of any piece of data and say, oh, okay, that's information that was published in 2018 and it hasn't changed since. Now imagine what that's like in 2118, looking back 100 years at data that is verifiably unchanged, from times eons ago. So over time, we think that this record will become the sort of default knowledge store for information that is important in the world. It's a way to signal that you think some information is useful to people in the future and say, hey, I want to remember this. I want the world to remember this thing that happened. And this is what we're attempting to achieve as a community. But we also see, and I think this is a very surprising property, that because information stored in this system is truly permanent, that is, even the person that uploaded it cannot revoke it later, you can build applications on top of this system that have fundamentally different properties. So you can think of data once it's stored in Arweave as actually ownerless. It's as if it is committed to the collective commons. There is funding put aside to pay for that information storage perpetually, and nobody can change it, and nobody can delete it after it's published. It's just kind of neutrally held. Well, that means when you apply that to web applications themselves, which are really just bundles of HTML, CSS, JavaScript speaking to the Arweave network as a database, which you can speak to it through GraphQL. When you think about it like this, you see that the application itself becomes ownerless. And this is really interesting, it turns out, because it allows you to do things like this. This is RWiki. RWiki is a Wikipedia-like system built on top of the permaweb where the community is sovereign. So what that means is that you can recall this RWiki page from any different Arweave gateway, and it will render in the same way. So the infrastructure provider and the person that developed it does not have preferential treatment or favored control rights to this information once it's published, this application once it's published. And this application itself delegates power to the community, and it has a whole complex system of how they want to govern themselves. But that system is enshrined in the code, and the code is immutable. So the community is essentially, well, they're sovereign. They control this space together in a way that is just not possible in Web 2. In Web 2, there's always someone that controls the servers. And what happens on the servers is what happens in the application. And so you can never have a system where your rights are protected from the person that controls the servers. Well, in the perma web, it's different because the applications are ownerless once published. Another example is this, Agora. Agora is a social media network inside the system, and it has these pretty profound speech preservation rights. If you can write to Agora one day, you can write to Agora tomorrow. There is no company or anyone else that sits in between your ability to write to the system. It's just you and the network. And as long as the network will take your tokens or payment to replicate the data that you want to put into it, then you will continue to be able to speak. There are other properties about these systems that are interesting as well. For example, permaweb applications preserve consumer integrity. And what we mean by this is best expressed by example, I think. So here is Weavemail. Weavemail is an application that was an improvement, or weve.email is an application that was an improvement on a rather terrible system that myself and core Arweave developer built called Weavemail.app back in 2018. And this improvement didn't supersede the old one. You can use the old one if you want to. And so with permaweb applications, because they're ownerless and nobody can revoke them after publishing, you get this strange property that developers can come along and build new versions, and you can switch to using them if you want, but they can't force you to. Well, compare that to Web 2. When you signed up for your email account, you didn't know the privacy policy that was going to be enforced 10 years later by the company with which you made your email account. You just had to kind of hope it wasn't going to be too bad. Or with Medium, which is a big blogging platform in the West, they had this system where everything was free and open, and you should publish your blogs on our platform, and you create your audience there. And then one day they came along and said, yeah, actually, we're going to paywall your content, and we're going to extract the money from the paywall, which people weren't very happy about for understandable reasons. If that was on the permaweb, you could just say, okay, I want to use a previous version of this user interface, and I refuse to update, and they can't stop you. It's kind of like with blockchains. I could try and create a new version of Bitcoin tomorrow that minted another 1 million tokens and gave them to me, but you guys wouldn't use it. It's exactly the same thing. I could try and make a new version of Weavemail that extracted more value from you tomorrow, but you just use an old version. And so your rights as a user are protected in this system. Also strange and cool property about permaweb applications is that they require zero maintenance after launch. So essentially what a permaweb app is doing is it is detaching, decoupling the code from the infrastructure and potentially the monetization. And so the developer has to pay to store the code. But this is pretty cheap because these bundles aren't very big. They're like 1 or 2 megabytes. It's half a cent a meg. Talking about like a cent to store your application forever. And then the infrastructure is the gateway that the user pulls that web application back from. So you can think of it like the user is commissioning their own infrastructure to use your app. And this is interesting because that means that the cost is now a sort of cost relationship between the gateway and the user. And it's actually very, very cheap to service a user on one of these things. So you can support it by ads, or you can support it by freemium models, or you can support it by whatever you want. The monetization for that infrastructure piece is completely modular, and the user gets to decide now. You can also use the free Arweave.net gateway, which is pretty good, and it'll just render those applications for you. But you can use another one if you want to as well. So the applications become portable between gateways, and the monetization for the infrastructure becomes a question for the user to work out, not the developer. And that means that you just like publish the code once, you pay once to put it out there. You never have to think about it again. It never stops working. It's like 24-hour uptime. The Arweave network has been down for 14 minutes in the first 6 days of launch, and never since then. It's been up 24/7 for 4.5 years since that point. Oh, yeah, 4.5, even longer now. And your application inherits that liveness property, just never goes down. You never have to pay for it. It's kind of cool. This monetization piece is super interesting because it's not just the monetization of infrastructure that you can make modular as well. You can actually do it to the assets themselves inside the applications. So we see that with the permaweb, one of the things you can do is you can tag your transactions. So every Arweave transaction has arbitrary tags that can be associated with it. And one of the things you can do there is start a contract inside those tags. So we could say, this is an NFT. And now I can start, I upload the file, I create an NFT contract inside that asset. And so it's what we call an atomic asset, because the single identifier refers not just to the data and to the metadata associated with it. So I uploaded it at a certain point in time with these tags, but also there's a contract inside it that says you now own it. And all of this is referred to by a single ID. And this is a sort of first-class citizen inside the web. So you can even get that information served back to you in HTTP requests and this kind of thing. We're exploring all sorts of ways to augment the network like that. But that means that you can essentially monetize assets on the web directly, embedded. And that's created websites like this. This is now.arweave.dev, or it's actually just called Now, and it'll come back on any Arweave gateway. Now is basically a Reddit-like system where you can upload pieces of information and say, hey, this is kind of cool, check it out, guys. Or I found this interesting thing on the permaweb. And then you can buy and sell interests in those pieces of data, those pieces of content, through this user interface. And then when people upvote, they're actually using this thing called Stamp protocol that lives on the Arweave network, which is kind of like a proof of attendance protocol. So a way of saying, hey, I found a cool thing to your friends. It's like, and then you can look at each other's feeds and say, oh, Sam is reading this interesting thing, or Alan is reading that interesting thing, whatever it happens to be. You can sort of follow what people are stamping, but also tokens are distributed proportionately to the things that people are stamping. It's kind of a reward for making good content. And those tokens aren't just given to the people that uploaded it in the first place, can actually be distributed proportionately to what we call a profit sharing token. So you can see here this down at the bottom, tradable atomic TX tutorial. It has this orange part. That means that some of those tokens are available to buy. And so you can buy into the profit stream of that piece of data on the permaweb. So you can see here it says for sale. We can just go buy some of it just like you'd expect in any other sort of crypto-like experience. And then when people stamp that, which is this sort of left-hand button here, then rewards are distributed to the owners of the asset. And you can do this with any revenue stream on the web. So imagine you have a YouTube-like system or a video hosting website that has a monetization from ads. Well, you can now distribute the rewards from those ads to the owners of the piece of content, and you can trade that. So imagine that you're going to release a long-form video on a video sharing platform. It's like an hour long, and you expect that the reward for that is going to accrue from ads over a 3-year period. It's kind of like a feature-length film or something. Well, this allows you to say, okay, I'm going to take 20% of that revenue that I'm going to make, that revenue stream, and I'm going to monetize it today. And I can sell that to you, and you can buy it for a price, and then you can just receive that reward. You can essentially purchase the future royalties from that piece of content. But it's not just video sharing apps, it's every single revenue stream on the web. The entire thing can be tokenized, and then you can build, algo traded funds on top of it and say, hey, we're really interested in buying into viral video revenue streams, or we're interested in blog posts, or whatever it happens to be. You can make different funds for different types of content, and you can unlock all of that value that is stuck inside these long, slow-flowing revenue streams on the web and make it tradable today, which is pretty interesting. And this is what the community is working on right now. So thank you all for listening. I hope that was a helpful introduction to the Arweave protocol. If you'd like to learn more, please visit arweave.org and join us in the Dev Discord server. We'd love to chat. Thank you.